All right, let's solve this deadlock. Here's the indexing idea I have. The indexing idea I have is to create a non-clustered index on country ID on the application countries table and include the country name. Now, the reason that I want to index application.countries is the select query wants a lock on that. And it doesn't want all of the columns in the table. It doesn't care about, for instance, latest recorded population at all. The query who is doing the updates, it's updating and incrementing the latest recorded population. Now, when you run an update and you're changing a value, that value is in the base table. So it's going to have to get a lock on the clustered primary key of the table. But here's the magic. If there are indexes in the table that don't contain latest recorded population at all, then the update query doesn't have to lock those indexes. So as long as we're creating an index for the select query that has all of the columns it needs, that covers the select query, it can use that non-clustered index and not have to go to the base table at all, the base table where the locking is happening. Let's take a look and test out this index in SQL Server and prove whether or not it prevents that deadlock. Here's the index that I say is a deadlock killer. We're going to create an index named deadlock killer on the application.countries table on country ID, and we're going to include the country name column. Let's go over and look at our query, who's the deadlock victim. On the application.countries table, it is joining on country ID. So I have that in the key of my non-clustered index so that it can quickly find the row it wants to join on based on the country ID. It is pulling back the country name as part of the query. Now, it's not prefixed CTRY, so you might have to do a little guessing assumptions or double check in wide world importers to make sure. It's a sloppy written query, but that's kind of the real world too, right? We don't have any other references to the country table in here, so that index on country ID include country name covers the countries table for the purpose of this query. Let's go ahead and create the index on the table. And this is a nice itty bitty table. It doesn't take any time at all. And then let's see if this works. So let's restart our sequence again. First up, our transaction begins and the first session updates application.countries just like before. Before it can get to the second part of its transaction, however, the query begins and something is different already. I got results immediately. This query didn't get blocked, didn't get stuck waiting for rows to come back. When I did this before, this second query was blocked and got stuck in that executing status. This second query, if I run it again, I've now turned on actual execution plans using this button here at the top, and I'm going to run it again. Looking at the execution plan, the map of how it ran this query, I can see that in this execution plan, I'm going to highlight one operator. It says I am using the IX deadlock killer index on the application.countries table. All of the other operators in here are for different tables. This one is state provinces. This one is for cities. This query no longer had to use the primary key, which is a clustered primary key on application.countries. So it could sneak right by on a different index. Now, back in our original transaction, it runs its second update and commits. There is no deadlock because another query was never blocked. This index gave a separate road for our select query to run on so that it didn't run into the update query transaction at all.